Okay, so where is it? Yes. So if ht is 0, okay, sorry. If ht is equal to 0 for all t less than equal to 0, then this implies that the system is causal. Okay, and otherwise it's going to be non-causal. And similar, so this is the first one. Second one is that if ht can be expressed in this form, k times delta n, okay, sorry, delta t is here in this case for continuous time. So k times delta t, it's going to be instantaneous system. And third one, and this is the most important, that if minus infinity to infinity mod of ht dt is less than some constant, let me say just my, which is less than equal to some constant my, which is less than infinity, then means if this turns out to be finite, so impulse response, this is called that impulse response is absolutely integrable. Okay, so means absolute value of if you take integration of absolute value of this impulse response from minus infinity to infinity, and that is finite, then the system is stable. Okay, so let me just uh, give you one few problems here and that you can try. So let's say that your ht is given by this e to the power minus of mod t. Okay, so for all time t, this is ht. Tell me whether this system is causal or not, whether this is stable or not, and whether this is instantaneous or not. Okay, so what is going to be your response based on conditions I have already discussed here? So this is kind of a summary. So based on this summary, can you tell me if this particular system given here is causal or instantaneous or dynamic or stable or unstable? Anyone?
Sir, non-causal.
Okay, so it is not causal or non-causal. You can write it non-causal and anything else. It is instantaneous or dynamic. So it will be dynamic, and whether it will be stable or not. So that is you will also have to tell me. So here in this case, it's going to be stable. Why it is non-causal? Because e of minus t, mod of minus t is like this, and plot it like this. Okay, and you can see that it exists for all value of time t. So for causal system, what you should have, it should only exist for positive value and not for negative values, right? So it's non-causal. And for the instantaneous system, it should be impulse located at origin, which it is not. I mean, it's located from minus infinity to infinity. So that's why it is a dynamic system and it's stable. If you integrate this e to the power mod minus t from minus infinity to infinity. So if you do this minus infinity to infinity mod of ht here, dt. So you will notice that this value here is always positive. So there is its mod value is actually equal to this only. So let me just write this. And this is going to be minus infinity to infinity e of minus of mod t and dt. And now we can break this integration into two parts. One will be from minus infinity to 0, another, so here it is going to be to the power plus t dt, right? And from 0 to infinity it's going to be e to the power minus t dt, isn't it? Right? So you can clearly see that this will be equal to e to the power t, and then you put minus infinity and 0. So it part is also going to be 1, and this is going to be, sorry, and this is going to be e to the minus of e to the power minus t. Okay, and when you put it 0 and infinity, it's again going to be 1 only. So it will be 1 plus 1, and that is equal to 2. Okay, so it turns out that this value minus infinity to infinity mod of ht dt less is less than equal to 2, right? It's equal to 2. I mean, there is no point of, it's equal to 2, which is less than infinity, which it means it is finite. So system will be stable. Okay, is this clear to everyone? ये सबको समझ
Yeah,
में आ रहा
yes, sir.
है? Okay, okay, very good now. So actually there are quite a few things when you start doing when you start problem solving, you will quickly pick on them. So my task here is kind of uncover them for you so that you just go and explore them. So you can take any good textbook on signal and system, and you can study that rest of the thing, and it will be uh, you will be able to complete everything. Okay, so now let me just go ahead, and now we will be discussing something. So there are many examples. Let me take one few more example that you can see whether you are able to do it or not. So another system is like this, that you have, let's say h of t is written as 3 delta of t minus 3. Tell me whether this system is causal or not. Okay, so just tell me whether this system is stable or not, causal or not, or instantaneous or dynamic. क्या होगा बता पाएंगे? Now, for what is condition for causality? That ht should be equal to 0 for t less than 0, isn't it? For all time t less than 0. This is the condition for causality, right?
Yes.
And does this impulse response satisfies that? So this is located at which point? It's an impulse, right? And its area is 3, and it is located at which point? T equal to 3 or t equal to minus 3?
T equal to 3.
3, right? So now you can see that this is actually satisfying this, isn't it? It's located as 3. So before that and after that it is equal to 0. So you can say that ht, from here you can write this, that this value is actually 0 for all time t is less than equal to 0, isn't it? Less than, I mean, we don't really see equality here, but for less than 0. Right? So it means that it is causal. इसका मतलब क्या है? ये causal है. Right? Next up, tell me whether it is instantaneous or not.
Yes, sir. Instantaneous.
No. So here ht is given as what? 3 delta t minus 3, right? ये दिया ना, और क्या लिया था मैंने? Okay,
Yes, sir.
3 delta t minus 3, right? Now for instantaneous system, what is the condition? That h of t should be equal to k times delta t. So instead of delta t here, what we have? Delta of t minus 1, right? It means it is not instantaneous, but it is dynamic system. Okay, यहाँ पे क्या है? V ये specifically क्या बोलता है कि you should have delta t, means at t equal to 0 only, not before that, not after that, and it should be equal to, it should be k times. So let me just try put k here. Okay, but here what you have, this signal here, that the one that we have 3 delta t, it is located at which point? T is equal to 3. Is that clear? So it is not located at t equal to 0. And that's why this is not a instantaneous system. So here 3 delta t minus 3, you can directly write this is not equal to k times delta t, isn't it? It's located as located at 3, t is equal to 3. So this way it is a dynamic system. So the system is dynamic. Okay, you got to solve few more problems to actually fully understand it, and it's obviously going to be stable, right? It's going to be stable. Why? Let's investigate that as well. So what we have is minus infinity to infinity mod of 3 delta t minus 3 dt, and this will be equal to 3, and mod of this, it is positive only. So this will be this only, delta of t minus 3 dt. And what is this value? 3 of minus infinity delta of t minus 3 dt. This will be equal to how much?
1.
1, right? So it will be equal to 3, which is obviously less than infinity. So it will be, system is stable. Okay. So is that clear to everyone?
Yes, sir.
Okay. So now what I'm going to do is we are going to discuss Fourier series representation of a periodic signal. Okay, is that clear to everyone? अभी हम लोग क्या करने जा रहे हैं? This is like system, basic system analysis is complete. I have discussed about basic system. So now what we are going to do is discuss about Fourier series representation of a periodic signal. But before learning about Fourier series, what we need to do is okay. So let me just save this. Okay. Okay. So, but before we discuss this topic, we need to discuss a very important topic, that is signals as a vector. Okay. So signal as a vector. Now this notion seems kind of disturbing to most of the people. Like a signal is a function. How can a function be a vector? Right? Isn't it? आप लोगों ने ये टॉपिक पढ़ा है पहले? Signal as a vector. Okay. So let's just go ahead with this. So the very thing, I mean, I'm not going to dwell into what vector is, but let me just tell you that um, if you can take linear combination of things, then that is basically a vector. Okay, so you have two what you can say mathematical uh, objects of same type. So this is one object and this is another object. And if you can take a linear combination of this, and this can be represented as, let's say, G, which is another object. Okay, then this X, Y, and G are vector. Is that clear? वेक्टर का मतलब क्या है कि आप उनका लीनियर कॉम्बिनेशन ले सकें. Even the one vector that we are familiar with, which is like this, okay, or something like this. So what we do, we take linear combination of this. So if you are essentially able to do this, take linear combination, then it means that it is a vector. And आपके पास अगर दो फंक्शन है, let's say ft और दूसरा फंक्शन gt, क्या आप इसका a ft plus b gt निकाल सकते हैं? a times ft plus b times gt, whereas a is just a constant and b is just a constant. Can we do this? Anyone?
Yes, sir.
It means, let's say this is f, something like xt or something like that. So it means ft, gt and xt functions are vector as well. Random variable आप पढ़ते हैं वो vectors है. Everything can be represented as everything is represented as vectors only. Okay, is that clear? And if you just want to be a bit more so, let me just see whether I have that or not. It should be somewhere, but sorry, it should be in PICT only. PICT, yes. Okay, let me just take this. Okay, let me just tell you what vector is here. I think I have discussed vector and vector space. Okay, so forget about linear algebra and all that. So a vector is related with vector space. You can't have a vector unless you have a vector space. For example, the vectors that physical vector that we are familiar with are three-dimensional vectors. So their vector spaces, that vector, that three-dimensional space only, they exist only there. Okay. So a real vector space is a set X with a spatial element 0. So there must be a null vector there and three operations: addition, inverse, and scalar multiplication. So if you are able to add two things, if you are able to take, there must be one X for which if you add minus of X, that will be equal to 0. And that is called additive inverse, and or sometimes called complement as well. Then another thing is scalar multiplication. So three operation must satisfy the following axioms. And these are, I mean, if what I told you in the beginning, that if you are able to scale them, if you are able to, add them, and if you are able to take linear combination, what is linear combination is the word, then you will be able to do all these operations. All these axioms are going to be satisfied. But just to be sure, let me just tell you that there is additive axioms that for every x, y, z in capital X, where x is the set of vectors, we have x plus y is equal to y plus z. X plus y plus z is equal to x plus. So I mean, there must be associativity, and there must be commute. So first one is commutative, second is associative, third is null vector, existence of a null vector. So you must have a null vector 0. So there can be a function which is 0 everywhere. And then third one, there must be a minus of x for x. And there are multiplicative axioms, and there must be just 0 times x is equal to 0 and 1 times x is equal to, I mean, so these are very simple things. And then distributive axiom. Okay. So I mean, it's the same thing that is applicable to, based on which you have all these very, very interesting algorithms in data science and all that, principal component analysis से लेके LDA से लेके सब कुछ जो होता है SVD वगैरह सब, it's all because of this vector only. Okay, I'm not going to dwell into that because we don't really need that much. For all practical purpose, what we are going to do, we are going to understand that a function that is there, if a signal that is there is basically a vector from which this is uh, it that you have to know. Okay, so a signal is a vector. Okay, there is lots of similarity between signals and vector. In fact, I mean, as I told you, signals are only vector. There is no way around at that. Okay, so ये सबको बिलीव हो गया कि सिग्नल वेक्टर है कि अभी और भी बात करना पड़ेगा इस पे. Hello.
Yes, sir.
Okay, so the definition that we study, that it has magnitude as well as direction. Direction has no meaning. It doesn't have any definition to say. Okay, so that is just for us to understand that there is a order there. Okay, so if you have some ordered pair, that is going to be a vector. So that is what that means. I mean, at some point we will talk about that. But for here, all you have to understand that function is basically a signal is basically a vector. Okay. Now, if signal is a vector, then we can represent one vector in terms of another vector, isn't it? So if I have a vector A, let's say this is the vector A, and then I have another vector, let's say this is vector B, then I can represent A in terms of B, isn't it? Right? So I can take A and I can take a projection of A, right? Which is, let's say, K1 times B. So this projection from here to here is B, K1 times B, and then some error vector here, isn't it? Let's say E1. Let me call this E1, right? And but this is not the only feasible way of representing A terms in terms of B. We can make it like this. So let me just take a few, I mean, few examples here, and then we'll, sorry. Okay, this is going to be third one. Let me just modify them slightly to make my point. Okay, so I can have this second one, which is like this, and then you have your error vector like this. Let's say this is A2E2 and this is K2B, and this is, let's say, K3B, and it is up to this point, and then after that you have, let's say, something like this. So K3B is, sorry, I'm unable to draw properly. So it is like this. So from here to here you have, okay, so you have your K3B here, and then this is E3. So here A can be written as K1B plus E1. Here A can be written as K2B plus E2. And here A can be written as K3B plus E3, isn't it? This in terms of vector I'm talking only, right? But which one of them is the right representation? I mean, all of them are correct, right? But if I have to take, what I'm saying is that which, if I will approximate this A in terms of K1B, okay, and here I can approximate A by, like, let's say K2B, and here I can approximate A by K3B. So which approximation has minimum error? Can you tell me? किस approximation में even first one, right? And why it is that? Uh, Sorry, am I audible to all of you?
Yes, sir.
Okay, so the one problem is that I lost, internet here in the college. I'm in college only, and I lost, sorry, power here, and that's why internet has also been gone. Now I don't know how much longer I will be able to continue with this, but जब तक मेरा बैटरी लास्ट करेगा और बैटरी बहुत क्विकली ड्रेन होता है. So we were talking about approximation of A as K1b or K2b or K3b, and which approximation is best? Can you tell me? कौन सा approximation best है? Anyone? किसमें error minimum है?
फर्स्ट वन।
फर्स्ट वन में, मतलब ये सबसे अप्रोक्सीमेशन अच्छा का मतलब क्या है? एरर सबसे कम हो, राइट? है ना? ओरिजिनल ए और उसके अप्रोक्सीमेशन को सब्ट्रैक्ट करोगे तो इनर एरर मिलेगा. वो एरर क्या है? मिनिमम कहाँ पे है? फर्स्ट वन में. ऐसा क्यों है? व्हाई इट इज दैट इट हैज द मिनिमम एरर? कैन एनीबॉडी डिस्कस अबाउट दैट और गेस अबाउट दैट?
सर क्योंकि K1B और A के बीच में डिफरेंस बहुत कम है।
वो तो कम है ही, लेकिन वो क्यों कम है? क्योंकि E1 जो है वो क्या है? परपेंडिकुलर है, राइट? फ्रॉम K1b टू A. K1b से परपेंडिकुलर है, राइट? आर यू गेटिंग माय पॉइंट?
यस सर।
यस सर।
So that is why, because K1b is perpendicular to E1, and because of that we will have this, right? So what will be this K? Okay, what will be the best approximation? A is equal to KB plus C, and when this C is minimum, जब ये मिनिमम होता है तो ये KB को क्या बोलते हैं हम लोग? We call this projection of A onto B. हम क्या बोलते हैं इसको? प्रोजेक्शन ऑफ A on to B. आप लोगों ने पहले ही पढ़ा होगा कि एक इवन इन वेक्टर एनालिसिस 11th में पढ़ा होगा कि एक वेक्टर है उसको दूसरे के टर्म में कैसे रिप्रेजेंट करते हैं, राइट? तो उसमें हम लोग क्या लेते हैं? प्रोजेक्शन लेते हैं ए का सेकेंड वेक्टर पे, और वट एवर एरर यू कैन ऐड दैट, राइट? इजंट इट? सो दिस इज कॉल्ड प्रोजेक्शन ऑफ ए. And what is the value of this K? Can you determine this? So here we have A is equal to KB plus C. Now we have to find out the value of C. So, sorry, this is E, error E hai. So this is error E. So we have to find out value of A. So what we can do? क्या कर सकते हैं आप? We can take its
Sir.
dot product with B, isn't it?
Yes sir.
And if you take its dot product with V, what you will be having? K will be equal to A dot B divided by B dot B, isn't it? तो इसको हम लोग डॉट प्रोडक्ट को इनर प्रोडक्ट भी, डॉट प्रोडक्ट जो है वो इनर प्रोडक्ट का एक टाइप है. इसको लोग इस तरह से भी लिखते हैं. ओके, मैथमेटिक्स में जाओगे तुम लोग, एडवांस मैथमेटिक्स में देखोगे तो हमेशा इसी तरह से लोग रिप्रेजेंट करते हैं. ओके, सो दिस मींस बेसिकली व्हाट? डॉट प्रोडक्ट और इनर प्रोडक्ट ऑफ योर सिग्नल. Is that or your vector, right? It means we can represent one vector in terms of other, right? And that turns out to be KB, और K की वैल्यू जो है वो that will be given by this, right? That will be given by this equations here. Now, can we do the same thing with the functions? And if we are able to do that, that is going to help us in a lot of way. Okay, so let's say that I have a function f of t, and I want to represent this function in terms of some other function. Let me call that gt. So k times gt, and then there will be this error vector. So let me call this et. Okay. So here error of approximation et is equal to what? ft minus kgt, isn't it? And this is, let's say, for this is what we are saying, that our domain here is between t1 and t2. So we are approximating not for all time, but for a certain period of time. Let me call this between time t1 and t2, isn't it? तो हम लोग कहाँ से कहाँ तक रिप्रेजेंट कर रहे हैं? t1 से t2 के बीच में ही ft को gt के बराबर रिप्रेजेंट कर रहे हैं. So that is one thing here to notice. So that is underlying assumption here, that we are representing ft as an approximation of ft is equal to k times gt plus et between time t1 and t2 only. So here error of approximation is going to be ft minus kgt, है ना? और हमें क्या करना है, हमें निकालना है कि what is going to be the best approximation, what will be the value of k that will do the best approximation here, right? That is our goal in the end. तो क्या होना चाहिए, ये error क्या होना चाहिए, मिनिमम होना चाहिए. Are you getting my point? Hello? Error of approximation होना चाहिए, minimum होना चाहिए, right? Now, if you notice one thing here, that this ET is actually function of K, and we want to minimize it with respect to K only, isn't it? So हम कैसे करेंगे, हम लोग क्या करेंगे, instead of minimizing ET, ET is not a value here, right? So what we will be doing, we want to minimize ET का size minimize करना चाह रहे हैं. ET is a function, isn't it? So we want to minimize its size. Okay, let me just remove this. We want to minimize its size. So what will be size? So this is between t1 and t2. तो हम लोग क्या कर सकते हैं, size क्या होता है, finite duration signal का energy, isn't it? So we can find energy of this ET, and what that is going to be, minus infinity to infinity, right? And this will be mod of ET whole square. So it will be basically ft minus kgt whole square dt, isn't it? This is E of et, and we want to minimize it. तो minimize करने के लिए क्या किया जाता है? How to determine minima and maxima? हम लोग क्या करते हैं, differentiate करते हैं, right? But if you remember, energy of this ET is not a function of time, it's function of k now, because integration हो रहा है तो t तो meaning loss कर गया. What is there? Only k. So it's a function of k. So we have to differentiate it with respect to k. So this dE energy of ET अगर निकालेंगे आप by dk, so what that is going to be, can anybody tell me? So I have integration between minus infinity to infinity. So let me just write d upon dk, and what you will have. So this will be f square t plus what you are going to have, k square g square t, and after that what you will be having, minus 2k ft times gt and dt, right? तो इसको आपको हमें differentiate करना है, right? And then we have to equate that equal to 0. So f square t जो है वो, that is not, it doesn't contains k. So this part is going to be equal to 0. And this second part where you have 2k square, that is going to be 2k g square t, and minus यहाँ पे क्या होगा, k को differentiate किया k के respect में, तो you will have 2 only, 2ft gt, and then you have this d of t, isn't it? And you have to equate this equal to 0. So from here you can see that the value of k, sorry, it is not minus infinity to infinity, it is between k1 to k2. Okay, so it's between it's kind of a It will be from K1 to K2, sorry, T1 to T2, because our signal is defined between T1 and T2 only. So it is from T1 to T2. Similarly, this is again going to be between T1 to T2. So this K turn out to be equal to minus infinity to infinity ft times gt d of t divided by, again, minus infinity to infinity. I can write this gt times gt and
Sir, hello sir.
हाँ बोलिए.
Your screen is freezed.
My screen is freezed. मे बी
Yes sir.
नेट कनेक्शन का थोड़ा प्रॉब्लम है. मोबाइल से कनेक्ट किया है. PICT Wi-Fi doesn't work. Let me just try to see if अभी भी फ्रीज है क्या?
हाँ सर.
अभी दिख रहा है? Is it freezed or is it visible?
No, it's not visible.
Okay. So I don't really have any other way. I'm unable to connect to PCT in broadband. Let me just save this first. Yeah, I may lost internet again. Okay. So मैं just quickly restart करता हूँ to see whether. Let me check if I will able to get this on work. Am I audible again?
Yes.
Okay, sorry. So I hope this will fix the screen problem.
Yes, sir, visible.
Okay. Okay, so this is what we were talking about, that we are representing this function ft in terms of some other function gt, and we have taken this as k, as we have done here with this function a is equal to kb plus e. And if we find this value of k, which is going to be the best approximation, then we will have a way of representing our function in terms of some other function. And this is error of approximation here, and this has to be minimum. But in that case, the error was simply a like a space signal, a space sorry, vector. But here in this case, this error we have to minimize its size, and its size is basically its energy. Then we try to find out its energy, and that turned out to be this between T1 and T2, and this is what we are getting K. So if you can notice here, so in case of vector, what we got is this. The K was equal to what? 8 times A dot B, isn't it? A dot B divided by B dot B, isn't it? And what we did there, we wanted to represent A in terms of B. So this was K times B, and plus you have some error vector E here. And here what we want to do, and here क्या है हमारे पास ft को हम represent कर रहे हैं kgt, and we have this error E of t, right? And between T1 and T2 we want to represent it. So ये K और ये K में क्या similarity है? Can you see some similarity between these two? Does they look similar or there is some difference there?
Sir, they are similar.
They are similar, isn't it? So this term here that is there. So this is again, I mean, I keep on making mistakes. Okay, so this is integration between T1 to T2, okay, because our signal is defined between T1 and T2 only. Okay, so you see that this A dot B here, A dot B is this term on the numerator is A dot B. So whatever term is here in the numerator, that must be ft dot gt, isn't it? ft का gt के साथ डॉट प्रोडक्ट है, होगा कि नहीं होगा अगर हम इन दोनों को कंपेयर करें तो, because they are basically vector. Only thing is that rules of mathematics are kind of different when you go from one domain to another domain. Okay, you may have the same kind of entity, but certain rules are going to change there, isn't it? Objects के हिसाब से change होते रहते हैं. So here we have integration, and here we have dot product. That is, I mean, that's quite a different thing, isn't it, than this one? But they are quite similar in some other way if you look objectively. So similarly, what we are going to define ft dot product with gt, and this is a time constant thing. So it will be between time t1 and t2, and it will be defined as ft. So in mathematics, it is slightly defined differently. So instead of gt, you will be taking g of complex conjugate of t, and then you will be taking this dt. So ft dot gt. So this is dot product of two functions or two signals between time t1 and t2. Okay. So what is this? This notation here is dot product of two signals between time t1 and t2. Is this clear to everyone?
Yes, sir.
Key dot product, and let's take some dot product here. Okay. So if ft is perpendicular to gt, what will happen? So here there is no meaning of perpendicular, but let's say if a is perpendicular to b, what will be this value of dot product a dot b?
0.
0. So when dot product is 0, we call them orthogonal, right? So for example, your I dot j is equal to what? 0. It means I and j are. This implies I and j are
Orthogonal.
orthogonal, isn't it? Similarly, when this term will be 0, we will say that between time t1 and t2, they are orthogonal. And let me give you some simple examples here to find out dot product. Let's say I have this one. So I'm going to draw picture here. One is our ft, another is gt. So our ft is like this. It's 1 between let's say 0.0 to 2, and I have another function which is let's say it's like this. It's again between 0 to 2, and its maximum value is again 1, but it's half wave of the sine. Okay, so what will be its functional form? First you have to find out, and this is f of t and this is g of t. So can you find me the dot product of these two? इन दोनों का डॉट प्रोडक्ट निकाल के बता सकते हैं मुझे क्या होगा? And what is the definition of dot product? I have already given here. And I have already told you, about incredible shortcut for doing these things, right? So you can employ those shortcuts here. थोड़ा सा zoom out करना पड़ेगा मुझे, I think, to make it visible, everything on the same piece. Okay. Okay. ये साइन का हाफ वेव है और ये रेक्टेंगल है 0 to 2 में और ये भी 0 to 2 में. तो क्या होगा इसका डॉट प्रोडक्ट? कैन एनीबडी टेल मी? सॉरी कितना है आपका? हेलो
2.5.
2.5.
2 divided by pi.
2 divided by pi. Okay, very good. So what we have to do is basically this thing. Let me do this in green color. So dot product निकालना है तो मतलब 0 से 2 के बीच में निकालना है time period. It is given as 0 to 2 here only. So one signal is 1 there. और complex conjugate का कोई meaning नहीं रहता है if you have a real signal, right? Complex conjugate is the same thing as this one. So this will be this signal. Let me just call that GT and DT. So what we are doing, we are integrating between 0 and 2 on g of t dt. And I clearly realized here that this is the half cycle of a sine wave. Isn't it? From 0 to 2, it's half cycle of a sine wave and its amplitude is 1 and this width duration is 2. So मैंने आपको क्या बताया था, ये कितना होता है? 80 divided by pi by 2, isn't it? So what is a here is 1, what is t here is 2, and then we are dividing it by pi by 2, so it will be how much? 4 by pi. आपका आंसर कितना आया था?
2 by pi.
So मेरे ख्याल से वो गलत है, ये 4 by pi होगा. ठीक है. What is the function that you have calculated gt to be? gt function क्या होगा? Amplitude 1 है, cos कॉस की जगह क्या होगा यहाँ पे साइन होगा, राइट? इट्स 0 at 0, सो इट मीन्स इट इज साइन, राइट? और क्या होगा इसके साथ? 2 पाई ओमेगा 2 पाई एफ नॉट होता है, राइट? तो एफ नॉट की जगह पे क्या होगा? टी नॉट कितना है? 0 to 2, सो 2 पाई बाई टी नॉट, सो 2 पाई बाई 2 होगा ये। तो ये कितना हो गया आपका? साइन ऑफ पाई हुआ आपका। And if you integrate, let me just do that in the next page. If you integrate 0 to 2 sine of pi, isn't it? Sorry, t naught is not equal to pi. So 2 pi by f t naught. T naught is not equal to pi, but t naught is equal to 4, right? It is 4. Sorry again. So this will be pi by uh, 2 pi. Sorry, let me just do this here. थोड़ा गर्ल्स फेयरली कर लेता हूँ मैं। सो जी टी विल बी साइन, हम लोग क्या लिखते हैं? 2 पाई टी नॉट, राइट? सो व्हाट इज टी नॉट? हाफ साइकिल 2 है, यानी पूरा टी नॉट कितना होगा? 4 तक होगा। अगर डॉट में ऐसे ले जाओ तो दिस पॉइंट विल बी 4, तो इसका टाइम पीरियड कितना है? 4। सो 2 पाई बाई 4, 2 पाई एफ नॉट टी ये होगा, तो दिस इज इक्वल टू साइन पाई बाई 2 टी एंड डी टी। सो साइन का इंटीग्रेशन क्या होता है बताएंगे आप? Minus of
Minus
cos
cos. Yes, sir.
pi by 2t, and this is divided by
Upon by pi by 2.
pi by
Pi by
2,
2.
isn't it? And we will put here 0 and 2, right? So अब ये बताइए, माइनस साइन है मतलब आपको 0 पहले रख सकते हैं हम लोग। So I'm going to take this pi by 2 here, and what this is going to be? Have I made any mistake here?
No, sir.
नहीं ना?
नहीं.
Okay, तो यहाँ पे क्या होगा?
1
0 और एक 1 आएगा, राइट? एक 1 आएगा और एक दूसरा क्या हो जाएगा? -1। सॉरी, 0 की जगह क्या होगा? -1 होगा। होगा? देखो 0 पे क्या हो गया? ये 0 मतलब cos 0 मतलब 1, एंड व्हेन यू पुट 2 हियर व्हाट यू विल बी गेटिंग? cos ऑफ पाई की वैल्यू कितनी होती है? -1। सो माइनस ऑफ -1, तो कितना हो गया आपका? 2 डिवाइडेड बाई पाई बाई 2, विच विल बी इक्वल टू हाउ मच? 4 बाई पाई। और यही सेम आंसर मैंने यहाँ पे निकाल लिया है by recognizing that this is half wave of sine and cosine। और हाफ वेव का एरिया कितना होता है? हाफ वेव, अगर हाफ वेव का ये टी नॉट मान रहा हूं मैं, ये विड्थ को मैंने टी नॉट माना, तो ये दिस विल बी a टाइम्स टी नॉट डिवाइडेड बाई पाई बाई 2। सो 1 times 2 divided by pi by 2, so that turned out to be 4 by pi here, and that is the same thing. So that's why I said that these shortcuts come handy in doing certain other things. And I mean, if you really are able to use them with their full potential, your speed is going to be very fast. Okay. So this turned out to be 4 by pi, right? So this is going to be dot product here, isn't it? Dot product of ft and gt. Let me give you some other signal now. So let's say I have this signal, which is like this. It's 1 between 0 to 4, and its value is 1. And I have another signal, which is also kind of a rectangular one only, but it's like this. Okay. Okay, आगे. So it's 1, and then it's equal to -1. So it is 1 between 0 to 2, and between 2 to 4 it is -1. So let's say this is ft and this is gt. What is going to be their dot product between time 0 to 4? Can you find out? आप लोग निकाल सकते हैं कितना होगा? How much this is going to be? आपको क्या करना है? You have to basically find out this 0 to 4 क्या है ft टाइम्स gt और dt करना है आपको। हेलो निकाल लेंगे।
यस सर।
ओके बताइए। अभी कितना आया बताया नहीं आप लोगों ने। कितना आया आप लोगों का?
सर 4।
फॉर मयूरेश राइट।
यस सर।
वेदांत आपका कितना आया? आर यू देयर?
0।
0. So this is going to be actually 0 only. When you multiply them, what will happen? अभी देखो FT और GT को मल्टीप्लाई करोगे तो आपको क्या मिलेगा बताइए। I mean it's 1 isn't it? FT is equal to 1 for 0 to 4. So GT को अगर 1 से मल्टीप्लाई कर रहे हो तो आप GT ही मिल रहा है ना आपको, राइट? So this is your FT times GT, isn't it? And this is 1 for 0 to 2 and then 2 to 4 it is equal to minus of 1. So if you integrate this minus infinity to infinity, ft times gt here and dt, sorry, not minus infinity, keep on doing this. Sorry about that. 0 to 4 here. So what this is going to be? 0 to 2 के बीच में कितना एरिया आएगा, उतना ही एरिया आपको 2 to 4 के बीच में भी आएगा, लेकिन ये निगेटिव होगा, राइट? So this will be positive and this is going to be negative, isn't it? And they will be exactly the same. So how much this is going to be? 0. Without integration, I can tell you that this is 0, but you can do the integration and find the same result. I mean, that's a very trivial integration. There is no point of doing that. Okay, is that clear? I would just want to tell you this, that what is cos t? Let me just 2 pi f naught t. Okay, and this is another is sine 2 pi f naught t. So we have cos 2 pi f naught t and sine 2 pi f naught t. Okay, and we want to know between 0 to t naught. Time period is given between 0 to t naught, where t naught is equal to 2 pi by f naught. Find the dot product of this and this between this time. Can you do this? निकाल सकते हैं आप लोग?
Yes.
Please do that. This is very important. कितना आया आप लोगों का? हेलो, मयूरेश, वेदांत, बताइए कितना आया? प्रथमेश, हेलो, आर यू देयर इन द मीटिंग?
यस सर।
कितना आया?
सर हाफ कॉस 2 पाई।
कि थोड़ा गड़बड़ कर रहे हैं आप लोग। लेट मी जस्ट शो यू व्हाट इट इज। अब ये बताइए मुझे, ये कितने से पेरियोडिक है? टी नॉट से। और ये भी कितने से पेरियोडिक है? टी नॉट से, राइट? और हम लोग इंटीग्रेट कहाँ से कर रहे हैं? 0 से टी नॉट तक, isn't it? So let me just do that, and it will be very simple. So we are doing this 0 to t naught, sine 2 pi f naught t into cos 2 pi f naught t, sorry, and dt. So I can multiply here 2 and divide by 2, isn't it? So how much this is going to be? Half 0 to t naught. And what you will be having here? Sine 2 pi, क्या होगा आपका? और 2 पाई की जगह हमारा क्या होगा? 4 पाई, राइट?
Yes, sir.
4 पाई एफ नॉट टी एंड डी टी। अभी ये कितने से पेरियोडिक है बता सकते हैं आप मुझे?
2 नॉट।
कितने से है? इसका टी कितना होगा? लेट से इसका पीरियड टी है, सो 2 पाई बाई एफ नॉट होगा। 2 पाई बाई ओमेगा नॉट, ओमेगा नॉट कितना है? 4 पाई एफ नॉट।
यस सर।
तो ये जो था टी नॉट से है, तो ये कितना हो जाएगा? ये क्या है बताइए आप मुझे? 4 पाई एफ नॉट डिवाइडेड बाई 2, दैट इज कितना आ रहा है हमारा? टू, सॉरी, 2 पाई बाई ओमेगा नॉट होता ना, तो इसका टी कितना आ रहा है बताइए मुझे। मैं आप लोग को दिखा रहा हूँ कि आपको इंटीग्रेशन करने की भी जरूरत नहीं है। व्हाट विल बी पीरियड ऑफ दिस? टी नॉट बाई 2 होगा। ये कितना है? 4, 2 पाई डिवाइडेड बाई आप कितना कर रहे हैं? 4 पाई एफ नॉट, राइट? तो कितना आ गया आपका? 1/2 टाइम्स, यहाँ पे क्या होगा? 2 एफ नॉट। तो 1 पाई एफ नॉट कितना होता है? टी नॉट। तो ये कितना हो जाएगा? टी नॉट बाई 2 होगा।
यस सर।
यानी आप ये क्या है, 2t में इंटीग्रेट कर रहे हैं, 0 से 2t। 0 से 2t के बीच में इसका कितना साइकिल होगा? हाउ
Sir,
मेनी
2
साइकिल्स?
complete cycles.
2 साइकिल होंगे, राइट?
Yes, sir.
अभी मुझे ये बताओ कि 2 साइकिल, एक साइकिल में साइन का एरिया कितना होता है?
0।
तो 2 साइकिल में साइन का एरिया कितना होगा?
0।
So this will be 0, right? You don't really have to do integration. You can clearly see that this is 0. But let's say that you want to do integration, then what this is going to be? 0 to t naught, and we are doing this. तो ये क्या हो जाएगा? साइन का इंटीग्रेशन कितना होता है? लेट मी अभी नया पेज करके कर देता हूँ मैं। साइन का इंटीग्रेशन कितना होता है? एनीवन?
माइनस कॉस।
So it will be minus of cos 4 pi f naught t divided by क्या होगा? 4 pi f naught, putting the value 0 to t naught. Just a minute. Okay, so what this is going to be? If we put this, I can take minus 1 by 4 pi f naught common here. And then what I will be having? Cos of 0, sorry, cos of, sorry, क्या होगा cos of 4 pi f naught and क्या हुआ t naught minus cos of 0 that is equal to 1. Core cos of 4 pi f naught t naught कितना होगा? F naught t naught is equal to 2 pi. कितना होगा? F naught t naught is equal to 1, isn't it?
Yes, sir.
So this will be 4 pi. Let me just remove this. Cos of 4 pi will be equal to 1, right? So this is basically minus 1 upon 4 pi f naught. And then you are doing 1 minus 1 and that will be equal to 0. Right?
Yes,
Yes,
sir.
sir.
अगर आप लोग का गलत हुआ तो कंफ्यूज मत होइए, बहुतों का गलत होता है यहाँ पे. साइन डूइंग इंटीग्रेशन ऑफ साइन कोसाइन आफ्टर लीविंग इट फॉर 2 years, इट्स नॉट दैट इजी. ओके, आप लोगों का 1-2 साल छूट ही गया है ना 12th के बाद. 12th तक सबको याद रहता है क्या होगा वैल्यूज ये, बट आफ्टर दैट वी डोंट डू दैट मच प्रैक्टिस एंड बिकॉज ऑफ दैट वी keep on making mistakes. So I'm going to end this session here. I just want to know that, tell you that. अब इसके आधार पे ये क्या हुआ, डॉट प्रोडक्ट कितना आया? This turned out to be how much? 0. इसका मतलब क्या हुआ, ये और ये दोनों सिग्नल क्या हैं? साइन ऑफ ओमेगा नॉट टी and cos of omega naught t are orthogonal. But you will have to mention here between 0 and t naught or over any time period of t naught. Okay, they are orthogonal. Orthogonal कितने किसके बीच में है? अपने time period के बीच में. Is that clear to everyone? So don't forget this 0 to t naught. Okay, is it clear to everyone?
Yes, sir.
Okay, and then we will move on our discussion from here to next lecture. अभी देखता हूँ मैं कल परसों में हम लोग इसको arrange करेंगे and we will try to since on मंडे ट्यूसडे वेडनेसडे हम लोग का काफ़ी देर हो जा रहा है तो हम लोग देखेंगे कि सैटरडे संडे कर लिया जाए. ओके,
Yes.
एंड वी विल कवर दिस फूरियर सीरीज इन कंप्लीट डिटेल. ओके, सो दैट फूरियर सीरीज में क्या है, क्वेश्चन लेंदी आते हैं बट इफ यू नो द प्रॉपर्टीज, इफ यू नो इट प्रॉपरली, तो आप अभी आपने देखा ना कि आप सारे इंटीग्रेशन यू कैन क्विकली कैलकुलेट एंड आई विल tell you tricks and tips where you don't really have to find out values and all that. आप बहुत जल्दी निकाल सकते हैं, ठीक है. एंड इससे हमेशा 1-2 मार्क्स के क्वेश्चन आता है, सो दैट विल बी वेरी वेरी बेनिफिशियल फॉर यू. सो डू नॉट मिस दिस फूरियर सीरीज एंड प्रैक्टिस इट. बहुत ज़्यादा मत करो, लेकिन मैं जितना करा रहा हूँ उतना कर लो. दैट विल बी वो बहुत आपको फायदेमंद रहेगा. फूरियर एंड सीरीज एंड फूरियर ट्रांसफॉर्म, इफ यू आर गोइंग टू मास्टर फूरियर सीरीज, फूरियर ट्रांसफॉर्म, लाप्लास ट्रांसफॉर्म and jet transform in complete detail, then you can be confident that you will get good marks in signal system as well as in network theory as well as in control system. Okay, so this is the main important topic जहाँ से start हो रहा है हमारे फूरियर सीरीज. और यहाँ पे क्या होता है, लोग बहुत गलतियाँ करते हैं, they make very silly mistakes and they end up getting negative marking here. And if you are, if you know all these property, you don't really have to solve, you will be able to solve them without lifting the pen. Okay, and I can get you there, you just have to be patient and walk through me, work throughout as I'm doing this. Okay, तो थोड़ा बोरिंग लगेगा आपको शुरू में, बट इट विल बिकम क्विकली वेरी वेरी इंटरेस्टिंग. ओके, सो आज के क्लास में हम लोगों ने ये सीखा कि साइन ओमेगा टी और कॉस ओमेगा नॉट टी आर ऑर्थोगोनल बिटवीन 0 to t naught. This is the most important result. Okay, so I'm going to end this lecture. Okay, all of you can
Thank
leave
you,
now.
sir.
Thank you for joining in. आप सभी लोग जा सकते हैं. I'm going to download attendance for record purpose only, and after that I'm going to end this session. So I'm now ending this session. Okay, thank you very much.
Thank you, sir.